Okay, we're going to take a look here at writing and balancing equations for each of the four reaction types. And this first one here is we're going to look at sodium and chlorine and how they produce sodium chloride. So sodium is Na, and the and is a plus sign. Chlorine, remember, is a diatomic molecule. Very important to remember that. If it's all alone, there will be two of them like that. So here with sodium, sodium is not diatomic, so there's not two of them. I just have one sodium, but chlorine is diatomic. So when it's by itself, I need to remember that. Put the arrow, leave a little space in front of all these, and then it produces sodium chloride. So again, just like we did last chapter, we're going to write sodium, we're going to write chlorine, and then we're going to write oxidation numbers 1 plus, oxidation number 1 minus, and we don't crisscross the ones. Now over here, if we wanted to write a 1 plus and a 1 minus, we could. There's nothing to cross them with, so we don't have to if they're all alone. So now we're going to look at balancing this equation. So I make my T-chart, left side, right side. We start out, we write down the different ions that we have. We have sodium and we have chlorine. We don't have any other ions. So then we look at the left side. How many sodium do I have? Well, there's no number there, so that tells me that I just have one. And you notice I want to leave a little space here because I might have to write numbers in. Chlorine right up here, how many do I have? I've got 2. Then on the right side, I'm looking right there and I see no subscripts in either spot, so that tells me I have 1 sodium and 1 chlorine. And for ones that I give you, they're never going to be balanced already. So if you think they are, you did something wrong in writing it. Often it's going to be if there's a diatomic molecule, you forgot that there has to be 2 of those. So check that if you think that you have it written incorrectly. So now we're going to balance this. We switch colors here, and what we're looking at is we've got 1 and 1 here, so we're good. So we're not going to worry about that. We're going to worry about this chlorine. And I have 2 of them on this side, 1 of them on that side. So I'm going to go over to the right side. I need to make 2 chlorine. Now remember, I can't put a number in between here because that is a compound. I need to put this coefficient in front of the entire compound. And that changes my chlorine. I had 1. It changes that now to 2 times 1. Cross that out, make that a 2. But that also changes my sodium, which I had 1, and now I take the 2 times the 1 that I had, changes that also to a 2. So now these are good because they're equal, so that's good. But now I need to look at my sodium. I have 2 here and 1 here, so I need to get 2 on the left side. So I'm going to put a 2 out in front, and that changes that to a 2. So checking that you got it right. Your equation down here, or your T-chart down here, you can see I have 2 and 2. I've got 2 of each, and you're just looking for these numbers on both sides, the left and the right, to be equal because of the law of conservation of mass. And then if you want to double check, I'm supposed to have 2 sodium on the left side. There's 2 times the 1 is 2 sodium. That's good. 2 chlorine. There's no number there, so that's a 1 times 2, which is 2. Over here I have 2 times 1 for 2, and I have 2 times that 1 for 2. So I double checked, and that is correct. Now look at the reaction type. I've got 1 thing plus 1 thing, and they're turning, so I have 2 things turning into 1. And that, remember, is a synthesis reaction. Synthesis reaction. Like a synthesizer, we have 2 things combining into 1. Looking at the next one here, we've got obviously a decomposition reaction. I give you a clue right there that decomposes. So we start out with fewer things, and they break down and turn into more things. So we have aluminum oxide. So I've got aluminum, I've got oxygen, and these 2 are together. Okay, aluminum oxide, and aluminum is a 3 plus, and oxygen is a 2 minus. So I need to crisscross, Al2O3. You've got to remember all 3 steps. First step, write the symbols. Second step, write the oxidation numbers. Third step, crisscross down and write them as subscripts. So when you're done, we're really looking at this, okay? And that decomposes, which means my arrow. Let me get rid of this first, okay? Decomposes, leave a little space, and it decomposes into aluminum by itself. Aluminum is just Al, but oxygen, remember, is one of our diatomic molecules, 7 on 7 and hydrogen. So oxygen, when it's by itself, is O2. So now I take a look and I make my T-chart. Left side, right side. Ions, what do I have? I've got aluminum, I've got oxygen, Al, and I've got O. And I don't have to look at the other side. All I need to look at is what ions do I have over here, aluminum and oxygen. I don't have any polyatomic ions in there, so I leave it like that. Okay, now, whoops, now I look at how many I have on each side. So on the left side, I've got aluminum, I've got 2 of them right there, so I'm going to put a 2 there. And oxygen, right here, I've got 3 of them, so I'm going to put a 3 there. On the right side, aluminum, I only have 1, but oxygen, I have 2. So now we can start with whatever we want. Since we don't have it broken up, I just start at the top, and I'm going to deal with the aluminum, and I'm going to try to get these to be equal numbers. So I need to get 2 on the right side, so I'm just going to put a coefficient of a 2 there. Remember, you cannot add a subscript. You can only add coefficients. So I'm going to put a 2 up there, and that changes this to a 2. I'm going to change colors here, put a 2 there, and that changes that from 1 to a 2. Okay? And now down here, I've got a 3 and a 2. So to get a 3 and a 2 to be equal, I'm going to go to 6. So I'm going to go over to the left side. Let's just start on the left side. I need to get 6. So if I've got oxygen, I've got 3 of them. What times 3 is 6? That would be 2. So I need to put that coefficient here. Remember, I can't cross this off and make it a 6. I can't put a 2 in there. The only thing I can do is put a coefficient out front. So I put that coefficient of a 2 there. It changes my oxygen to 6, but it also changes my aluminum. 2 times 2 changes that to 4. So now let's just stick with the oxygen because that's what we're dealing with. We need to get 6 oxygen over here. I've got 2, so if I put a 3 here, I now cross that off, I have 6. And now the last thing I need to get to be the same is the 4 and the 2. So if I go over here, and this is one of the tricky ones because now you've got to actually erase this. And when you erase this, you got to look at how many you have, okay? So when I erase that, wait, what did I have there? I had a 2 there already. That was already a 4, my bad. Oops, whoa, hold on. Let's back up. Okay, there we go. So when I put that 2 there, I should have changed that to a 4 originally. So then it's gonna be balanced at that point. And again, double check. 4 aluminum on both sides. There's 2 and 2 make 4. And 2 and 2 make 4. And on the oxygen, I should have 6. So I have 2 times 3 is 6. And I have 3 times 2 is 6. 4 equals 4. 6 equals 6. It's balanced. And again, we said that was a decomposition reaction. Now I take a look at this one, lead 2 nitrate. So we've got Pb2+. That's what this 2 tells me. That's a 2+. Nitrate, remember, is NO3, and that's a 1-. That's a polyatomic ion that I'll give you. You need to crisscross. You need parentheses there, and put a 2. And then it reacts with, that's a plus sign, potassium iodide. That's K, and that's I. That's a 1+, and that's a 1-, so I don't crisscross. To produce is my arrow. Lead 2, which is Pb, 2+ again, and this is iodine, and that's a 1-, so I crisscross the 2. And potassium nitrate, K. Nitrate is NO3, 1+. This one I'll give you is a 1-, so you don't crisscross there. So I want to double check that I got everything crisscrossed. I did, so now we're good. So now I can set up my T-chart. Now, on this one, I've got a polyatomic ion in here. So I've got Pb. Since I have nitrate here, and I have nitrate together over there, I'm going to put it in my T-chart as nitrate. So I'm going to put NO3. If they would split it up and have nitrate over here, but over here they would have like nitrogen and oxygen, then I would have to split it up on the T-chart. But they don't do that, so I can leave that together. I also have K and I have I. So now I look at how many of everything I have on the left and the right. I've got lead, I've got just one of them. Nitrate, I've got 2 outside the parentheses here, I've got 2. Potassium, I've got 1. Iodine, I've got 1. On the right side, for lead, I've got 1. For nitrate, be careful, I don't have 3 of them. I don't have a parentheses with the number outside, so I only have 1 nitrate. I've got 1 nitrate there, I've got 2 iodine, and, oh wait, my bad, I've got 1 potassium, and I've got 2 iodine. So I can start with either this or this, because these are the things that are different. I'm just going to start with my nitrate. I need to get 2 of them over here, so I'm going to change colors. I'm going to make a 2 there, which makes that a 2, but this 2 also affects my potassium. I had 1 on the right side, and now I've got 2. So again, when I put this coefficient here, it affects this, and it affects that. Now, I'm going to deal with the iodine, and on the right side I've got 2, on the left side I've got 1. So I'm going to put a 2 here in front of this, which changes that to a 2, and then that also changes my potassium to a 2. So now I look, 1 and 1, 2 and 2, 2 and 2, 2 and 2, it should be balanced. You could double check it up top, and you would see that it is. And this one, I've got 2 here and 2 here, and they cross. So the lead was with the nitrate, and now the lead's with the iodine. The potassium was with the iodine, now potassium with the nitrate. So this would be a double replacement reaction. Double replacement reaction. Last one here. We're going to have hydrogen chloride, which is H, hydrogen, Cl, 1 plus, 1 minus, and iron 2. It doesn't matter that it's a 2 plus, I can write it, but it doesn't cross with anything. And that produces iron 2 plus, chlorine, which is a 1 minus, so I crisscross the 2 only. And then be careful again, because hydrogen is diatomic, so it's H2. So you notice the iron over here is just Fe, but the hydrogen over here is H2 because it's diatomic. So you got to be careful with that. So now I'm going to balance this, and we're going to go hydrogen, we're going to go chlorine, and we're going to go iron. And we've got 1, 1, and 1. Over here we have hydrogen, we've got 2, chlorine, we've got 2, and iron, we've got 1. So I'm just going to go with my hydrogen, and I'm going to put a 2 out front here, which changes that to a 2, and my chlorine also to a 2. And you can see it's now balanced. These are all equal. In this one, I have a single ion here, and over here I've got a different single ion. So the iron was alone. Over here the iron's with the chlorine. So it was a single replacement reaction. Single replacement reaction. So there's a little review on all 4 reaction types and how to balance those equations.